The example goes from aerospace technology, and from aerospace industry. It's very nice industry actually, because they sometimes invest a lot of efforts in order to get the result. It's new and always requires some new design. And that was about the design, as a difference in design of spacecraft rocket launch system. One was designed by Soviet Union and another one was designed by America. And well, the technical problem that we had in hand was very simple. You have to hold a rocket before it goes, before it starts. You have to hold it. So definitely it is erected like vertical. And then it goes and flies, and it is, you know, supported by the jet. But in the very beginning, it has to be held by something, because if it is released a little bit earlier, then a wind gust could come, and the rocket falls, and it's, of course it's impossible. At the same time, if you hold it too firmly like this, then the rocket already starts going, and you have to release it. So you have to design a technical system of support of the rocket, which releases the rocket exactly at the moment when it is able to go itself. And it's quite sounds like a standard engineering problem. And well, for example, my background is control engineering, and of course it is so easy to design beautiful system. We have a lot of sensors. You have some, I don't know, a kind of pneumatic system, for example, or I don't know, hydraulic system that holds it and releases exactly the moment at the moment when it is necessary. Okay, but the problem is when it disappears, everything is burned. Everything is burned to ashes, because, you know, plasma comes out of combustion, and therefore everything is burned. So you have obviously rebuilt it every time, after every launch, and so you will always have job if you are a control engineer, and everyone is happy. And that is basically the design that was implemented by American team. And you know, at that time America was competing Soviet Union a lot in aerospace, and they were fighting to be the fastest, the first person to go to moon or to the space at all. And well, they implemented it, and there is a video in hopefully in the presentation, then you see that there is a design. This video was openly accessible. There is a link, you can check it, and this is a nice video of the launch of Apollo 11th spacecraft. And as you see, after maybe third minute, like looks like everything is burned. What you see is actually the fire. So there is 6 minutes of fire. So everything is definitely burned, and they put a lot of water on the launch system in order to cool it down a little bit. So you see either fire or steam or nothing, because you cannot see anything through the steam. And and you see, since everything is burned, then definitely you have plenty of engineers installing the system again and again. And let us try to play with the definition of ideal final result. So ideal system is no system, but you can hold the rocket, and the rocket is released exactly in the moment when it is necessary. And let us also play with a, let's say, more aggressive formulation of ideal final result. We need a rocket support system that does not exist, but exactly the moment when the rocket starts, it releases the rocket. So it's a little bit even ambitious, you know, it is an operation time concept, when you exactly need it. And if you see the video with the start of a Russian rocket, well, actually you cannot see it a lot, but but you can somehow mention that the system seems to be much more elegant actually, because possibly that this idea of ideal final result was in this or in different form somewhere deep in the head of designers. So Russians designed a very simple system to ensure the rocket to hold itself. To hold itself. You remember, itself is a very important word. Well, to make a long story short, the idea of the system was like this. So when you install rocket is really heavy. So, you know, hundreds of tons maybe. So when you install it, it holds itself. There is like a simple mechanical system, and it will be shown in the slide. Like it is installed and holds itself, and there is a counterweight. So when exactly at the moment when the combustion starts and the jet is generated and the rocket starts going, it loses its mass, not exactly the mass, but it stops pushing on the system. So and and counterweight starts working and the rocket goes. And it is so simple, so funny, so nice. It's really easy. And of course, nothing could be burned because there are no sensors, there are no hydraulics, nothing, no wiring, no controllers, and so it's so easy to implement and dirt cheap, I guess. And there is also a picture of the patent of the Russian design. The patent was recently given on another story, but you see, and there are some round-shaped counterweights that typically just simply indicates how it works. And I would like to emphasize why it is so beautiful, because it can work only with a rocket. So if you compare it with American design, that is, let's say, ugly from point of view of TRIZ, why it is ugly? Because it can work without rocket. So if you want to play with it with your joystick or with your remote control, you can make them moving even without rocket. But in this elegant design of, let's say, Soviet Union design, that it is technically impossible to make them moving without rocket. And it is a good sign of ideality. I would love you to remember it. So the good system works only when it is necessary and exactly where it is necessary. Bad system can work always.